Next, let's look at example 2. The percentage of Americans who say it's morally acceptable to use stem cells obtained from human embryos was 52% in 2002, and it increases by 2.25 percentage points per year. Alright, so we want to find a model for this situation. So the first thing we're going to need to do is set up some ordered pairs. Then we're going to find the slope and go on to find the model. Let's take a second to think about the kinds of information that were given in this problem. 52% in 2002 sounds like an ordered pair. It's a grouping of two values that correspond with each other. And the fact that it's increasing by 2.2 percentage points per year sounds like a slope value. So as we begin writing the equation, we know we're starting with a slope or m value of 2.25. And we have an ordered pair of 0 because we're starting at years since 2002. 2002 is 0 years, and 52%. Now we need to write the equation. Notice that the ordered pair that we're given is the y-intercept. That's going to make it awfully handy when I go to write this equation. My equation is going to be in the form of y equals mx plus b. I know the slope. The slope is 2.25, and I know the y-intercept. The y-coordinate of the y-intercept is 52. So just like that, we have our equation. We're going to want to put this in terms of the variables for the problem. So instead of using x, we'll use t, and instead of using y, we'll use p for percentage. We can even use function notation here and write this as p of t. In part B, we want to predict the percentage of Americans who say it's morally acceptable in 2010. So what we're looking for here is find p of 2010 is going to be 8 years since 2002. So looking for p of 8. Let's grab that calculator again and multiply. P of 8 turns out to be 70. So in 2010, 70% of Americans say it's morally acceptable to use stem cells obtained from human embryos. In part C, we want to predict when all Americans will say it's morally acceptable to use the stem cells. All is going to represent the percentage 100%. So if I plug 100% in for p of t, I can solve for t. We'll start by subtracting 52 from both sides of the equation. That's going to give us 2.25t equals 100 minus 52 is 48. And then to solve for t, we're going to divide both sides by 2.25. So we get 21.33. Since this is a year value, we're going to need to add that value onto our starting year, which was 2002, which will give us the year 2023.33, or sometime during the year 2023. We predict that in 2023, 100% or all of Americans will say that it's morally acceptable to use stem cells during research. In the next example, we're going to translate algebraic expressions into English sentences. What different words could be used for the equal sign in x equals 5? You could use equals or is, so both some common words, or something like results in, just as a few examples. In example 4, we want to write the equation for the following sentence, then solve it. So we have 7 times the difference of a number and 3 is 35. First of all, we're looking at 7 times the difference. So I know that when I start this, it's going to be 7 times a quantity in parentheses. So that quantity in parentheses can represent an entire difference. And that difference is supposed to be the difference of a number and 3. So x and 3, we'll have x minus 3. The next piece is negative 35. Is my equals word, so equals negative 35. So that's the equation. Now we got to make sure that we solve it. When we solve it, we're going to start by distributing. So we're going to have 7x minus 21 on the left. If we add 21 to both sides, we'll come up with 7x equals negative 14. In example 5, we're going to simplify the expression or solve the equation as appropriate. Example B, we want to do 8 minus 2 times the sum of a number and 5 is 12. So we'll start with our 8. Now we're subtracting 2 times a sum, so 2 times a quantity, and the sum is of a number x and 5, that result is 12, so we have our equation. Distributing gives us 2x minus 10, and we'll want to combine those like terms, the negative 10 and the 8. That'll give us negative 2 minus 2x equals 12. And to solve for x, we'll add 2 to both sides. Negative 2x is equal to 14, or if I divide both sides by negative 2, I'll have x equals negative 7. In example 6, we want to solve the equation by looking at the graphs. This grid has the equation y equals negative 3x minus 5 graphed, and y equals 1/3 x plus 5/3. In part A, we want to solve the equation 1/3 x plus 5/3 equals negative 3x plus 5. So I want to find out when the two equations are equal. We're going to be looking for that intersection point. So we're looking for the value of x here. It appears to be negative 2. In part B, I want to find when 1/3 x plus 5/3 equals 2. So I'm only going to use the second equation. I'm going to find out when I have a y value of 2. So a y value of 2 is going to happen on that graph at the x value of 1. So the answer there is going to be x equals 1. For example 7, we want to use a couple tables to solve this equation. Remember that I can solve this equation if I separate it into y equals each side of the equal sign. So we'll separate it into y equals 6 minus x and y equals 3x minus 2. We need a couple of values here for x and for y. Let's start with negative 2, negative 1, 0, 1, 2, and 3. And we'll find the y values. Once you complete the tables, you're looking for an ordered pair that they share. And in this case, they're both going to share the ordered pair 2, 4. So the solution to this one is x equals 2. Remembering that we don't include the y value in the solution. The y value is the value that both sides are equal to when you plug in 2 for x. Alright, the last topic in this section, some definitions. A conditional equation is an equation that is sometimes true and sometimes false, depending on which values are substituted for the variable. A conditional equation will have one solution. Sometimes equations don't have any solutions. If this is the case, we call the equation inconsistent and say that this type of equation has no solution. Other types of equations are true for all possible values of the variable. This is called an identity. We say that this type of equation has all real numbers as solutions. Let's look at an example. The first thing we want to do with this equation is to combine like terms. So 3x minus 7x will give us negative 4x. And 5x minus 9x will give us negative 4x. Now you want to get all of your variables on the same side. So you'd want to add 4x to both sides. But what happens there is you're left with no x's since negative 4x plus 4x is 0 on both sides. So we're left with a statement like 2 equals 8. 2 equals 8 is not true. And since it's not true, this equation has no solution. This is an example of a type of equation that is inconsistent. The answer will be no solution because we come up with an inconsistent or not true statement as a result. Let's look at the next one. The first step in simplifying is to remove the parentheses using the distributive property. So we'll have 8x minus 12. Then to solve, we're going to add x to both sides of the equation. That gives us 9x minus 12. We'll add 12 to both sides and get 9x equals 17. Or, by dividing by 9, I'll get x equals 17/9. The type of equation that gives one solution, where I solve for x and get a value, is a conditional equation. So in the first example, we saw an inconsistent equation. In the second example, we saw a conditional equation. And in our third, let's get rid of those parentheses. We'll make that 2x minus 10. And then combine like terms. We've got negative x and 2x. Those are going to add to 1x. So we can kind of already see it happening right here. We have the same exact thing on both sides of the equation. So when I subtract the x from both sides to solve, the x's are going to eliminate, and it's going to leave us with negative 10 equals negative 10. Negative 10 equals negative 10 is a true statement. So this type of equation is an identity. And the answer is all real numbers. So once again, let's compare these. If I get x as an answer, I get a number for x. I've got a conditional equation and my answer is just the number. If I get something where the variables completely eliminate, it depends on whether or not the statement is true or false, what my answer is going to be. If it's true, because the equation is an identity, the answer is all real numbers. Or if it's false, it's not true that 2 is equal to 8, then the answer to that would be no solution.